Hi gang, a few of you have been asking about Stirling engines, so I thought I'd build a single-cylinder Stirling engine and take you step by step through the construction. At the end I'll show you some of the problems I ran into and how I solved them. To help you follow the construction, here's a little bit about this single-cylinder design. It's called a single-cylinder design because there's just one outer cylinder that contains the working fluid, which is air in this case. The air inside it gets heated down here. This other cylinder is a solid mass that moves up and down. When it moves down, it displaces the hot air at the bottom, forcing it to move to the top. So this cylinder is called a displacer cylinder, or just a displacer. The displacer moves up and down under the driving force of this flywheel. As the flywheel turns, it repeatedly lifts and lowers the displacer. In this case, the connection between the flywheel and the displacer is this crankshaft and this thread. Since it is a thread, gravity does some of the lowering too. The other main part is this flexible diaphragm, which in some designs is a piston. In this case, it's just a balloon that's connected to the crankshaft using these two connecting rods. It looks like the flywheel lifts up on the diaphragm, but it's just the opposite. Hot air expands, and even though most of the hot air is at the bottom at this time, the overall volume occupied by the air is increasing. It's that increasing volume of air that inflates the diaphragm and pushes up on the connecting rods. That turns the crankshaft and adds energy to the flywheel. That's what keeps the flywheel turning and makes the whole thing work. When does the air cool down again? It cools down while it's in the top part of the cylinder. When the displacer comes back up, it forces the cool air back to the bottom so that the whole cycle can repeat again. Now let's go step by step through the construction. I'll start with the single cylinder, which in this case is a can. The can is a tomato paste can, and it is about 5 centimeters wide by 8.5 centimeters high. Next is the wooden frame that holds it all together, and it works like this. The can goes in here, and then this piece of wood right here is a tight fit. Just wedge in there like that, and that holds the can in place. The only really important dimension here is the distance from the bottom of the can to this hole here. There's one hole right there drilled and another one on the other side, and they're lined up. And that distance from the bottom of the can to that hole is 16 centimeters. The displacer cylinder needs to fit inside this can, but air needs to flow all around it. So the can is 5 centimeters in diameter. I'll make the displacer cylinder 4.5 centimeters in diameter. The height should be about 6 centimeters. I have this piece of balsa wood here, and I'm just going to create enough layers of this to build up as close to 6 centimeters as I can get. This is the coat hanger wire I'll use for the crankshaft, and it's a fairly flimsy one. I usually hate them as coat hangers. This is another coat hanger wire, and it's much stiffer, so I'm not going to use that. That's probably going to be hard to shape. Now the actual cranking part is only about 11 centimeters, and I could have about 10 centimeters sticking out on each side, so that's around 31 centimeters, around a foot basically, or 30 centimeters. And this central portion of the coat hanger is actually around 30 centimeters. As you'll see, these aren't the crankshaft dimensions I started out with, but they are what worked out in the end. And there's the finished crankshaft. For the connecting rods, I'll use this piece of 5mm square balsa wood. And I'll cut two pieces 8 centimeters long each. And 1 centimeter from the end of each one I'll put a small hole for the crankshaft. I picked a drill bit that was a fair bit larger than the crankshaft. That's so that this can easily be put on at any time or taken off at any time. Next I need to take this paper clip and make a little loop that can hang down from this middle piece right here, and it can swing around it freely, and the displacer cylinder will hang from that. There's the end result. Hopefully that'll work. Okay, I've taken it apart so I can assemble it with the shaft. Oh, seems to work fairly well. I'll use this balloon for the diaphragm. Just need to cut it. I can always trim it more later, so I'll cut it fairly long. Next I want to attach a thread to the displacer cylinder. So I'm going to push this nail into the displacer cylinder. And I'll make the thread for now about 1 foot long should do. Next I'll mark where I think the very top center of the balloon is. I threaded a needle onto the thread from the displacer cylinder. I'm just going to push that needle up through that mark. Go. Now the connecting rods also have to be attached to the top of the diaphragm because it's the expanding diaphragm that pushes the connecting rods up. So I'm going to take 2 thumbtacks and just from inside the balloon I'll push them up through. I'll move them about a centimeter or so away from the thread that I just pushed through on either side of the thread. I'm not quite ready to put it on the connecting rods yet. Next thing I need to do is stiffen the diaphragm a bit, and to do that I've cut these 4 little pieces of cardboard, each one about 1/2 centimeter wide by 1.5 centimeters tall, and I'm going to glue them in a cross pattern on top of the diaphragm just to give it some stiffness. Next, to connect what I have so far. First, to attach the connecting rods using the thumbtacks. I'm going to put on the rubber band at this point. Give me a good air seal there, although it looks pretty good anyway. Okay, so next to tie the thread in place, and it goes through the paper clip that's hanging down here. The way you want it is when the paper clip's at its lowest, the displacer cylinder is at its lowest. That way, as the paper clip rises, the displacer also rises, and when the paper clip's at the top, then the displacer is at the top. Here's the flywheel. It's just an old piece of wood that I had. Made a hole in the middle that was the right size for the shaft, stuck the shaft through, bent the shaft, and then put 2 staples just to hold it in place. That works fine. And lastly, some tips. This wasn't the first crankshaft I made. In fact, it was the 4th. I started out with this big one right here and gradually shrank and shrank and shrank until I was satisfied with this piece, but these 2 pieces still had to shrink. And the reason is because of the distance, the lengths of the connecting rods, the balloon was having too much trouble moving them through the distance that they had to travel. As you saw, I initially just pushed the thumbtacks up into the connecting rods, but I later went back and added hot glue to make them hold on better. Well, thanks for watching. Check out my YouTube channel, rimstar.org, for more videos like this, as well as other Stirling engine videos. There's one on how to make a Van de Graaff generator, one on how a crystal radio works, and another about a Fresnel lens taken from a rear projection TV. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you soon.